Hello, everyone. Thank you again for joining us for another OpenShift Commons Community call. Really happy to see you all here. And today we have a great topic on zero trust and zero privilege. So zero trust networking with Marc Curry and zero privilege architecture with Marc de Jong. And if you haven't watched the Lightboard, it is a fantastic 4-minute overview of a zero privilege architecture, but I'll let Marc talk about that more later. First, some quick announcements. Again, join us in KubeCon. We have the registration open, as well as the registration open for OpenShift Commons and Raleigh. So both of those, I'll put those in the notes doc again. And if you have any topics that you would like to have covered, please put those in the notes as well. And really quickly, since I didn't do this last time, I am Karina Angel, and I am the OpenShift Commons lead. And first, I would like both Marcs, if you can introduce yourselves briefly, and then Marc Curry, I'll give you the floor.
Sure, I'll go first. My name is Marc Curry, and I'm an OpenShift product manager, and I'm responsible for networking and performance and scale in the product.
And I'm Marc Jong. I'm an engineering lead in ING, mainly focusing on cloud native workloads.
Awesome, thank you both. Okay, Marc. Zero trust networking on OpenShift.
All right, thanks, Karina. Well, so I have a topic this morning which is new and old at the same time. So we have a zero trust effort at Red Hat. That's not new. What is new is the effort that we're putting into ensuring that we have a strong zero trust networking story at Red Hat. So I'm going to talk a little bit about that today, and with a brief introduction to the bigger picture. So let's kind of back up for a second, and what's really meant by zero trust networking specifically. Well, the end goal is that our customers, they want to assume that everything is independently and always exposed to all potential threats. That is, there's a bad actor in their cluster somewhere, and so how do we mitigate any possible threats? And so this is a little bit like if you've ever worked with security enhanced Linux, SE Linux. The idea, major part of the idea, and I'm sure the other Marc will expand upon this some more, but the major part of this is to mitigate lack of imagination attacks. And so you want to get to a point where everything is denied except for that which is expressly granted, and that can minimize that sort of a surface of attack. So this is where our customers want to be. The kinds of customers that want this are across the board, but of course there's everything from public sector customers to banks and even organizations like health organizations that have regulatory compliances that must be met. So what is it specific about zero trust that we're doing with the networking part of this? Well, this was really, this larger effort was catalyzed by, in the United States anyways, but this is true in other countries around the world. The United States, this is really catalyzed by White House Executive Order 14028, which is all about improving the nation's cybersecurity. But really, if you're doing any sort of public sector work at all, then you need to ensure that your product and their deployments are protected in a very zero trust way, for lack of a better way to describe it. So that's what this is really all about. That's why we are expending this effort. And I'll talk a little bit more about what the effort actually is in a bit. But where are we today? Without any configuration whatsoever, Kubernetes is by default fairly open. It's a fairly, almost like, I kind of think of it as an academic-like environment. And so all of the trust that's established is very implicit. So one thing I hear a lot from customers is, well, my cluster is on a dedicated trusted network. that may be sufficient for some customers, and for others, it's completely insufficient. So we want to have those onion layers of security, and where we really want to be is we want to be moving towards explicit trust. Again, going back to what I said before, lock everything down. If you've ever done any kind of firewalling, you start off with a deny all rule, and then you poke holes only as needed and specific to those that allow the function of your cluster or your application. So that's where we need to be. And so is it any one thing that's going to do this? No, it's a bunch of things. So I'll come back to that in a moment. So what exactly, where is Zero Trust at Red Hat? Well, this is definitely not new at Red Hat. So there's a rather large amount of momentum of Zero Trust at Red Hat. This was sparked by, in particular, there's a lot of people, but in particular, there's a couple of gentlemen. There was John Dvorak and Mike Gepley that are both architect level engineers that have really built a huge amount of everything from collateral to configurations and so forth to enable Zero Trust across the board at Red Hat. So, why are we talking separately about Zero Trust networking in particular? And does that mean that's already done? Well, no. So we do have Zero Trust throughout our entire Red Hat portfolio. There are all kinds of tools that come into play to either configure it, to assist with it, to provide it. For example, Ansible in the configuration side of things. We have identity platforms, varieties that we support. There's an entire security ecosystem of third-party partners that we work with, and all of their functionality that comes to play on an on-demand sort of basis. We have obviously some rather mature service engagements that we engage in for Zero Trust. And so there's a lot of different capability of Zero Trust that already is in existence. And so what I'm talking about is just one more layer of it, and that's applying it to the networking of OpenShift. So let's dive into that then. So what exactly is the story for Zero Trust networking within OpenShift? So let's start with first the status of where we're at today. So as I said, there already is a rather large amount of effort around Zero Trust in Red Hat in general. There is another layer of Zero Trust enablement by our security team, in particular Kirsten Newcomer and others. But if you look at what's out there today, it's not advertised very well. It's not described very well. There aren't very good how-tos with regard to Zero Trust networking. And if you do read some of the collateral, a lot of it kind of centers around two very important aspects of security, IPsec and network policy. But there is so much more capability that can be brought to bear to flush out Zero Trust networking that it's not, I would say it's definitely far from complete. And it's not easy for our users. If we start them off and say, go ahead and enable Zero Trust networking, I'm pretty sure they wouldn't really know where to begin, except maybe the more experienced folks that have configured it before. They might start to poke around to find what they need. So what we're really, and we also realize that no single product technology is going to solve it, right? So it's not just network policy. It's not just IP tables or NF tables or whatever. Though some of these layered products I'm going to talk about have greater contributions than others. For example, OpenShift Service Mesh, it actually solves a great deal of some of the foundational requirements for Zero Trust networking. However, we have customers that simply cannot or will not deploy Service Mesh for a variety of reasons. And so we, in particular, cannot require, going back to no single product, we can't require Service Mesh for Zero Trust networking. For those that are using Service Mesh, we can provide guidance and information about how to use Service Mesh to bring to bear all the different aspects of it that need to be enabled and configured. But then we also have to have an alternate path for those that cannot use Service Mesh. We also have some additional layered products, the Advanced Cluster Security, Advanced Cluster Management, also known as ACS and ACM. They also have major contributions to Zero Trust networking. And so essentially what they can provide in addition to, OpenShift is providing sort of a federation of things across all of OpenShift. So ensuring that not just that cluster is locked down and secured, but all 100 or 1,000 of your clusters are locked down and secured in a manner as you see fit. Maybe you do not want any snowflakes, or maybe there are a few snowflake configurations that you have to manage and maintain. So we bring to bear all the things. So high level, what exactly are we doing with regard to zero trust networking with OpenShift? Short term, we already have pretty much all the elements in one form or another. So we're going to build upon what we've already got, and we're targeting the end of this calendar year for the first enablement of zero trust networking. Again, we can't require every solution option or existing product solution, but we are going to optionally provide them. We have a lot of customers that have already enabled this in one form or another, maybe through some internal tooling that they've created, or maybe using third-party products. So we just simply want to say, here's what you can do with some of the major capabilities of zero trust networking, and then pick and choose the ones that make the most sense for you. So for existing solutions today, it might literally be just a matter of documentation. Here's how to use all the capabilities we have. Here's some more information about them. Here's a how-to configure them, and here's some caveats and other considerations. After that first initial documentation effort, then, and literally it might end up being more like just a chapter of our product documentation, so a fully supported implementation how-to and pathway. But then we will, at that point, identify, so what gaps exist that we're hearing back from customers, and then we can then actually do core development to provide additional solutions to cover some of those gaps. And of course, we have very rich partnership with a large ecosystem of third-party solutions. And the point of that being that we can't always solve those gaps, or not in a time or a manner to suit every particular customer's unique situation. So this is where third-party partners definitely come in and enhance the overall solution. So we continue to work with them. So what are the targeted capabilities? I'm sorry, I didn't mean to turn this into an eye test here, but just at a high level, these are the things that we're initially targeting for our first sort of documentation effort of approaching zero trust networking. This is absolutely not a exhaustive list of things. One of the things that we need to be when we do this is we need to be agile enough to understand that the threat environment is always changing. And so we need to be able to adapt to that in a very quick manner with an industrial strength solution. And so, but this is absolutely, when you talk to customers, this is absolutely top of mind for them. And there is a huge amount of investment out there. In fact, if you poll, we polled lots of customers and asked them where their greatest spend was and where their greatest focus was. It was on security, surprise, surprise. But in particular, network security was at the top of that list. So this is everything, like I said, from public sector to financial services industry to healthcare organizations and so forth. But it really is not just for really large customers, but it really should be part of the stable for any deployment of a Kubernetes cluster. So what we're going to do is we're going to take all those capabilities and we're going to match them up to our existing products and capability providers. And this is also a non-exhaustive list, but we have a lot of things. Red Hat OpenShift networking is not, a lot of people associate it with Kubernetes CNI plugin, but it's far, far more than that. The plugin is a bullet point to all the things that the networking provides. And in fact, zero trust networking will be yet another bullet point to what it provides. But we're going to build upon all of these things, again, in an optional way, so that if you are, for example, using service mesh, or if you do have virtualization requirements, then we can you can build upon some of that existing capability to deliver zero trust networking, and we'll show you how to do it. And so that brings me basically to the end. But if you want to find out more about this and get a lot more information about what are the other things that Red Hat is doing around zero trust networking, or even what's the bigger picture of zero trust, especially with regard to Kubernetes, then I provided several links here that you can follow up on to dive deeper into the topic. But I want to thank you for your time. I really just want to provide this as a high-level overview of what's coming down the pipeline, and also what our current capabilities are today to provide this. So you don't have to wait for our documentation effort, but that'll probably help a lot of people greatly in their journey. So thank you.
Thanks, Mark. We do have a couple of questions in the chat, and feel free, everybody else, to drop more questions in the chat, or after David asks his, you can feel free to jump in. Yeah. So David, would you like to go ahead and ask your questions? If I'm putting you on the spot, otherwise I can ask them for you. All right.
No, I had to unmute myself. I hit the button. Push the button. Hey, Mark, good presentation. Yes. 2 questions for you. How big of a footprint is this from a technology standpoint? Is this looking like, can I put this, is this going to take a data center to do all this? Is it going to be, can I put it on a, I don't say Raspberry Pi is not the right word, but a NUC or some type of a, laptop, desktop, server? What's the footprint? And the secondary question I had from that standpoint is, how many people does it take to totally implement this? 1 person, 2 person, 10 people? Because what we find from a small business standpoint is, yes, we could delve into the technology, but then that eats into something else, whether it be another person or another capability somewhere. It's kind of like a, like a rob Peter to pay Paul type atmosphere. So how does this all work in that side of the fence?
Great questions, David. Let me try to address them one at a time. I can answer them both with sort of the answer you don't want to hear, which is it depends. But let's address the first one a little bit beyond depends. And so, how big of a footprint is this? I say depends because we have customers that are deploying something. Think of it at the size of a Raspberry Pi at the very far edge, all the way to customers that have 500 plus node OpenShift deployments in a rack and deep in a data center somewhere. And we have customers that have hybrid footprints with multiple clusters all attached and working together. So it kind of depends in that sense in terms of the footprint and what your resources, physical resources, are to do that deployment. It also depends on where you're deploying. So if you're on, say, Amazon's public cloud, there are additional native capabilities there that you can take advantage of that wouldn't be there on an IP camera in a parking lot somewhere of a large retail organization. So it really depends on what resources you have available to you in terms of what the footprint is, but it's key to understand that it's entirely under your control. You can implement that which you require and that fits within your footprint. Zero trust networking is not 10 things. It's whatever things make sense for your deployment. If you have unlimited, or reasonably large resources, then we strongly recommend that you build out those onion layers with all the different kinds of capabilities. But again, that's going to depend upon what your capabilities are. Your resources are. On the second question, how many people does it take to do this? The depends part of that is literally the same exact answer for some of those things. It kind of depends on what your deployment looks like. But also, a thing I hear a lot from customers is that the cluster administrator is on a team completely different from the security administrator. So the security administrator basically says, do whatever you want with your cluster. However, here are the guardrails you have to stay within for proper security before we will allow it onto our corporate network. So those guardrails can really determine what other teams do you need to speak with, and therefore what additional people do you need to work with. So it could be multiple people from the perspective of that isolation or those pillars within an organization. But really, where you want this to be is kind of counter to that, which is you want proper security to be something that can be managed in a very automatic way. And that generally results in a minimal of staffing to do it. So you want these things to be protecting you from those lack of imagination attacks. And a key part of this is observability. And a really good observability configuration is one that doesn't make you keep going in there and checking it once an hour or whatever the frequency might be. It's something that's proactively alerting you to something that looks a little off. And then you have your other layers of security that are protecting you, so you don't have to run in to the data center on the weekend still toweling off from the shower you were in. So the idea is that there's something that's going to help you take care of this and actually hopefully minimize the number of people that it requires to do it. But again, it depends on several things. Hopefully, David, that answered your question.
It did. It just, like I said, it was like one of the, it depends type, question. And it's just, being that zero, from a cybersecurity standpoint, zero trust networking, people trying to implement something like this, easy, much more, quicker is not the right word, but more palatable than if, it's a long drawn out process with a bunch of people involved, et cetera, et cetera. And if you have to do all this stuff, this, that, and the other, it'll never get implemented because it's more of, if everybody gets involved and they're like, I need this, I need that. It's just like more chiefs in the kitchen versus the Indians to run the show. And so that's what I'm trying to, kind of get an idea from your standpoint from a zero trust network is how does that, how does that work in the realm of cybersecurity, et cetera, because of, it's a need, not a want now from all the stuff that's going on.
That's correct. It's even stronger than that. Not only is it a need, I would argue, but it's actually a mandate now for some organizations, right? So if you're working at all, for example, with the federal government, it's now a mandate that you have verifiable layers of strong security. So yeah, it's one of those things where you're not throwing out everything you've learned about fundamental security over the years. You're just simply applying it, and you have new tools in your toolbox to do that. And so, we're not changing deny all, then poke holes. That's always been true. That likely always will be true. However, we have other things in the works having to do with automation around Ansible as well as AI, right? So AI is one of these things that can weigh out lots of metrics constantly and make reasonably intelligent decisions about what to do, and you provided just enough leash to do the things that you feel comfortable allowing it to do. So there's a lot of things that are happening in that space, but the goal is there should really be something that someone, for example, the network operations center is alerted to up on the big screen in the front of the room. And then something is automatically taking care of it and alerting that it happened, that the event was there, and then everything's being recorded for later inspection. So it's really, how far do you want to go? But nobody would ever accuse you of having too much security, except for maybe developers, right? They want to have kind of free, open access to everything. But that's a negotiation thing with them and between them and the security administrators. Okay, I've done a lot of talking there. Does anybody have any other questions?
Thank you, Mark. I wonder
Absolutely.
if you want to I know you've worked with Marc Jong before. I wonder if you want to set up the zero privilege architecture, since it's a subset.
Yes. So, Marc next is going to talk a little bit about how to really think about your overall architecture. So how is it that you should approach, for example, following the documentation that we're putting together on all of these things? How is it that you should take that and build out a proper architecture that's verifiable, observable, and locked down to reduce some of those collective imagination attacks? So Marc, I'll pass it on to you.
Thank you very much. Yeah, indeed, I'll talk about how we at ING look at zero privilege architecture specifically for the runtime domain. This is a sort of a rerun of the slide deck we did at KubeCon in Europe in April. So it's a presentation from my colleague Thijs and Diana. I changed one slide, which is the introduction to me. Just the next one. I'm an engineering lead within ING. Like I said, mostly focused on cloud native workloads, which is mainly focused around our container hosting platform within ING. And like I said, I'll do a subset of the slides. The full presentation is also available on YouTube if you want to go into all the slides. But there's some stuff specific to KubeCon because it's located in Amsterdam. So talk about Dutch folklore. But I'll skip those. But the important part is starting here. In the Netherlands, we learned to evolve the hard way with being underwater and that kind of stuff. But it's advised to avoid the path and adapt in time. I use the application applicable wisdom available, and let's start with this one. In general, people believe this is a quote from Darwin, but it's actually coming from Leon Magazine. American professor for management and marketing. From his publication, Lessons Learned from Europe for American Business, he states, it's actually not the strongest of the species that survived, but nor the most intelligent one, but it's the one that is most adaptable. And this observation was obviously based on Darwin's Origins of Species, but the lessons actually that today's cyber threat environment calls for IT landscapes that adapt and adjust quickly, or else they will just stop to exist. And how bad does it get for IT systems? These might not have proven impactful enough, but we should really start addressing our security issues. All the examples here aren't even covering the damages done to those losing their privacy, reputation, and wealth. When will we as an IT industry start to take real ownership and of the responsibility to secure the data entrusted to us by society? How sure are we that your data organization isn't next in line? Would you like to spend the rest of your career looking for and plugging holes? Or do you really want to save, do you really think this will save you in the long run? Or would you make a difference, start reforming and address the fundamental issues? So there's some insights into the common weaknesses, and I hope you'll see them. This picture shows a typical application stack. I think everybody will agree on this one. You have the OS at the bottom, application on top, really traditional, and all the agents and endpoints in between. In theory, if we rely on least privilege principle, all of these layers should only have a minimum set of permissions to do their actual task. But there's self-updating capabilities, for example, and what do they actually mean from an access perspective? In practice, anybody with the slightest motivation is apparently able to get elevated privileges in that model. And public cloud is not any better in this. But could it actually be worse? Yeah, you have thousands and thousands of instances of those stacks. And usually with all of those credentials for all of the systems, many organizations keep them identical, resulting in APT highways because it's easy to just hop over between environments. But imagine if waterworks, electricity, and the postal services request you to change the cylinder of your door and your house to a generic key shared with everybody else in the city. Would you accept that in real life? That's not really a way forward in that model. There's a popular example, I guess, in the recent past, which is SolarWinds. They had a system called Orion, which is used by a lot of companies to manage IT resources. But they broke into the SolarWinds systems and added malicious code. This is a really known one, of course. This is the example of nobody's in control of software lineage. In addition, people usually trust software from IT solutions they purchase, but don't take into account that those might be overprivileged. For example, if we go back to SolarWinds, the elevated privileges used by the Orion components enabled lateral movement and takeover of systems. And therefore, relying on zero trust implementations does not compute if the fundamentals of it are shaky at best, which is not really a surprise. Wiseman already highlighted the dangers of not addressing weaknesses 2,500 years ago, which is actually a man called Sun Tzu, the author of the book The Art of War. But let's take this quote. The opportunity of defeating the enemy is provided by the enemy itself. It's a nugget of wisdom we can apply to IT infrastructure as well. Imagine if if we actually address the fundamental IT weaknesses. For example, from an APT perspective, its victims provide the opportunities. But if you take care of your weaknesses, then the attackers cannot exploit those points anymore. Even with limited budget, you can tackle most important blind spots. So the lesson here is know your weaknesses and address them. And we'll share some typical advantages. The current state of affairs, regretfully, is not the most. Current state of affairs, regretfully, is that most good folks are living the movie Groundhog Day, which is a fun movie, of course. Every day they scan, patch, chase false positives, and report on their activities. And whatever the outcome is, the next day they will do exactly the same. So we're not keeping ourselves busy with solving the problem, but we're just rerunning the things we usually do. Will bolting on more of this help? I don't think so. We keep adding more and more into the ecosystem, but if you use every piece of tooling in there, you're getting way too much cognitive load on your environment. So we need a paradigm shift. And we need to get away from bolting on security, which is what sometimes happens. But we shouldn't use this approach. We used it for decades. And we see where it is now with our average IT security posture. Even adding more detection and response won't save you in the long run. Bottom line is that we're failing at cybersecurity a bit. Global spending is at 190 billion a year, but it doesn't really buy us. So we should aim for actually secure by design. Take responsibility of the system security at design time, fix the fundamental issues. I'm pretty sure the team building these did a thorough analysis of to be executed threats and either countered these or mitigated the worst in the design phase. And some proper testing was done before any VIP actually sat down in one of these. And of course, just this vehicle in itself is not enough as standalone, but they need to integrate into the larger security ecosystem. I'll skip this one, but we're currently playing for a draw, but we should be playing for a win. That's the most important part. But let's look at what the industry produced in the recent years. Desired state infrastructure has become basically a commodity. If you look at Kubernetes, namespace as a service on top of Kubernetes has matured. Infrastructure as code, policy as code have matured. CI/CD has matured. Eventing based on topics is a mature industry pattern. Data persistence as a service is available, like key spaces, buckets, topics, table spaces. Observability is available both in a classical way, but also as anomaly detection. And exposing all metrics via endpoints is quite mature with Prometheus, for example. And infrastructure, identity management as a service is also available. All of the above are all of the above are a commodity in public cloud, and with a little bit of effort, you could get them properly working on private cloud as well. And we need to look at best practices, which have been around for quite some years, like separation of non-production and production, CI/CD, test-driven development, SDLC, network segmentation, 12-factor application development. But I think we need to be very opinionated and specify intended use of these. So we have additional lessons from the past to support that. But you really need to look at specific use cases and not one tool to rule them all, for example. I'm not I lost the name of this fellow. But there's 2 lessons. Immutable infrastructure over irresistible security advantages. That's the lessons from the quotes. So you need to, in the design phase, you need to take in the human element to see what might even happen. But the rashness is important in this one. Thick fingers could cause any problems. But also, a fast-moving environment can evolve more quickly than an actual compact plan can be adapted to that fast-moving environment. So you're always too late if you come up with a complex plan to cater for security, but the world has moved on already. I'll quote my colleague on this because I didn't actually do this, but he attended aerospace engineering classes quite some time ago. And a quote hit a nerve. Perfection is not achieved. Perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. The mantra in aerospace engineering is if you construct something, it needs to lift something to the Earth, from the Earth's surface to the moon or anywhere else. But the lessons here being security is achieved not when there's nothing more to add, but when there's nothing left to take away, which is the actual true outcome of least privilege in our model. Least privilege. Zero privilege is actually not very special. It's not new. Manufacturing industries are doing it actually today already. There's no natural persons in the process line for building any of these products. And if you want to change something, it is always done via a really strict process that needs to adhere to anything. But how can we apply this to an IT platform? Let's combine this. We end up with 2 basic outcomes for what zero privilege architecture should align with. Any change to the system is the result of a control process, for example, desired state, meaning that changes cannot be done by a single natural person, whether inside or outside your organization. And the other one being any component of the system runs immutable yet ephemeral, meaning in case it no longer conforms to the desired state, it is killed and redeployed via the process described in Principle 1. A warning to all eager marketers: zero privilege is about a secure system design. It's not about products. How can this be implemented? You need a CI/CD pipeline, which would be the only entry for changes to the system. No more patching or whatever in any shape or form. You always do a redeploy. The hosting platform itself is immutable and offers immutable namespaces to host the application workloads. Communication patterns are always push out 5 topics. Oh, great. Wrong button. Okay. Go. Communication patterns are push out instead of connect in via agents or any agentless MPAs or whatever. Any data ingested, processed, or created, exported in the system is stored separately in a separate environment away from the runtime environment, preferably in a read-only state. Technical state compliance monitoring and anomaly detection should be part of the platform. And events are pushed out from the platform towards a topic for monitoring that environment. Identity access management becomes simple for production runtime platform. There's no privileged accounts for any natural person or agent, being zero privileged. But there's some important distinctions here is that for this environment, the ordering of the flags are a bit observability and testing must be mature because you're not no longer allowed to do anything in production at all. So all golden signals and events need to be pushed out so that people can use an overall view of everything that's happening in the environment. When it's necessary to break the class, because there might be potential cases for breaking the class, where, for example, your CI/CD pipeline is broken, there's a need to return to normal. The way to do this is by removing everything and redeploying. In this case, it would be, for example, removing the entire namespace, removing all access to the namespace, removing everything in there, recreating the namespace, and then let the consumer redeploy their workload into a namespace. But other important parts of this entire flow is that you need to have automated compliance, vulnerability scanning, automated testing, and software asset management as well. But the important thing here is that they also interface with the CI/CD pipeline and not with the runtime. So everything goes via CI/CD. And that's the source of truth for everything. And there's just a correlation between what's actually running, mapping to the artifacts created in the CI/CD pipeline. There's another important thing that needs to be addressed here is that the organization, of course, needs to adhere to it as well. And we realize this overview might appeal to architects, engineers, developers, and so on, but there's also a bunch of other stakeholders that we need to convince. And I'll skip this one, but stop compensating, like we said prior to this, and you need to address your fundamental issues. This is a short elevator pitch. Do you keep your organization alive in a cyber threat landscape? You should really redirect investment to fix fundamental issues instead of spending on compensation, like doing the day-to-day, how you'd always do it. How? By investing in refactoring applications, a zero-privilege infrastructure, automate everything, segmenting domains to reduce blast radius, and importantly, invest in your staff for skill and awareness, because that's really something that you need to fix as well. But the actual benefits that you might reap from it is that you significantly reduce the risk of unsuccessful or successful ransomware attacks. You stabilize the environment by a significant reduction of operational errors, because there's no change, and significantly reduce the risk of bad press, fines, and personal consequences due to data leaks. Additional benefit, you're better to support your core business as well, because there can be more time put into that estate. This is an important one from Sun Tzu as well. The stronger your defense, the less you're interested. You're an interested party for any defender. So it's bad for other people, of course, that your defenses are good, but for yourself, it's always good to be the best at defense so that there's no offense possible. And this is an overview for, well, we won't go explicitly through all the aspects, but there's two defenses that make an adversary think twice. Adversaries can no longer take over privileged accounts because they don't exist on the environment. But also anomaly detection rules in TCM become definitions have become policy as code in quite literal the sense. So everything will be enforced via policy as code. And a really important distinction that I might not have told in the previous showing of this overview is that also for SIEM XDR and for operational monitoring, everything goes back via CI/CD pipeline. So that's the only way in. So you have full control over your CI/CD pipeline. And that's the only way to actually do something. So the important things here for technical state compliance monitoring and anomaly detection is TCM is for monitoring the settings of the system so that you can close the loop on changes. And anomaly detection is to analyze for any unexpected events, if anything does seem to break. And next to that, you also need vulnerability scanning, but that's only valid for known vulnerabilities. So you need to extend that into unknowns as well. Slide deck stopped working. Okay. That's all nice in theory, of course, but can it actually be built? Yes, it can. We've been running this since the actual immutable platform since last year. And prior to that, we had a previous version which was mostly immutable, which sounds weird, but it was the case. It's a different maturity level. We have been running our own mandatory pipeline implementation for CI/CD since 2019, which is the way to deploy, in our case, to the container platform as well, but to any other environment. This is also the mandatory pipeline. So all controls are in place here. And the platform itself has been running about 50% of the calls towards ING's mobile app, and fully running on the container hosting environment, serving millions of customers a day on a daily basis. It really works. this is a context for the pupil. I think I need my next slide. This is one you need to read because we apologize towards a bunch of security developers and CISO members and all kinds of other stuff, because we basically we do respect you, but we need a definite paradigm shift to win against our adversaries. So we need to make sure that everything goes into the fundamentals of fixing stuff. Let's see, which slide am I on? Okay. I'm almost done. The biggest question is sometimes for this architecture is that your workflow might not fit, which is definitely the case because it's basically focused on a fully immutable environment. So it's a full API landscape with no persistency at all. So your workload needs to adapt to that to be able to run, which is an important thing. And to map back a bit into zero trust in a more generic level, there's still application access, right? This is mostly around the actual runtime. So it's still possible to connect to any application that's hosted in a zero privilege environment. But similar principles should be used on those application environments as well, if possible. But there is a sort of architecture boundary at the hosted namespace in this case, which for us seems to be a logical split between the zero privilege on a runtime environment and then the zero trust on the application level. That's the last slide. Actually, if there's any questions towards our implementation or any ideas behind the problem, welcome to ask them. And like I said, there's a YouTube video for the entire slideshow with all the context, if you want to follow it. And the slides are also available on SlideShare. We'll share the link as well.
Thank you, Marc. I see that Kirsten is here. You're able to join us. I was wondering, Kirsten and Marc Curry, kind of your thoughts on this, because this is also a call out, right, to product. So any initial thoughts, given that you have worked with Marc in the past? But
yeah, I'll just say, and then hand it off to Kirsten, that this absolutely plays into the plan, right? So going back to the conversation and where I mentioned lock everything down and then only open up that which is explicitly allowed. I think that speaks directly to the one of the more fundamental concepts of what Marc was talking about. I know Kirsten is doing plenty of that, way beyond just networking.
Yeah, so thanks so much for this, Marc. Great presentation. Thanks again for sharing with all of us. One of the things I love about the kind of approach demonstrated here is that, sometimes I get asked about ransomware and how do we protect against ransomware. And so if you look at managing everything as code, your infrastructure, your configurations, your policies, your security policies, as well as configuration policies, that really sets you up to minimize the impact of a ransomware, as well as to manage this kind of zero privilege, zero trust approach, right? You get kind of a double bang for the buck, and you can start by just, even without all the very tight zero privilege controls, making sure that you're managing this as code and that you can recreate an environment is such a win. And this is something we do see at our customers. We have many OpenShift customers who have organized their environment in such a way that they regularly redeploy it. It might be every 6 weeks, it might be every 3 months, but they want to have a clean start on a regular basis, and they work with their app dev teams to make sure that those are easily redeployed as well. So it shifts. That doesn't mean you still don't need to think about the security for where you are storing those code things, your pipeline, your playbooks, your YAML configurations. You've got to ensure that you've appropriately secured those. But it's such a great win, and definitely, again, with this kind of approach, you get a twofer. So
Thank you very
you
much.
still have to back up stateful data too, by the way, if you're worried about ransomware. But
Yeah, well, indeed, but indeed, specifically in the immutable workload domain, there is no backup because it's just a redeploy. So indeed, catering for a secure environment where your code and your config actually lives, that's an important part.
Seems
love
like
it. I see in the chat we have a customer who rolls every 7 days. Awesome. Yeah.
Seems like that would make it easier for upgrades too.
Do you also roll your control plane?
Question for you, Tom Manor.
Actually, they do not, and the reason why they don't is because there is right now their clusters, their control plane clusters have been running, their control plane nodes have been running for over 2 years because of the upgrade process. There's a couple of RFPs that are in to be able to make sure that they can roll those nodes, but there's something with the control plane where it's not easy to, during the upgrade of a cluster, to swap out an entire node during the control plane during the upgrade process. And so we're driving some RFPs for Coles to try and to help with that. But that is something that they've asked for, because they would like to, for their security posturing, they'd like to be able to flip out their control plane nodes as frequently as they do their worker nodes.
And I see, David, you had your hand raised.
I do. Excuse me. The question I have from this standpoint is, I know folks have been saying, and this is an OpenShift question, or OpenShift, how do I call it, talk. But what would it be to say, hey, if I want to put business critical applications on a separate network, an actual physical network, versus having it exposed to the outside world and then having that network behind, let's say, like a VPN firewall or something of that nature? So you're not necessarily having it open to the worldwide, anybody can just jump in there and touch it. You have to have some type of a security, like a VPN or something like that to look at it or work with it. Does that make sense? Or is it something that I completely messed up?
I'm hoping Marc can help with that one.
Yeah, sorry, I only got part of the question, but I believe so let me restate it. I believe the question was, how does this help when you have something like a VPN and somebody doesn't normally have access to get through that VPN to get to the cluster? Is that the nature of the question?
The question I was thinking was, let's say you have all your business critical applications, whether it be monies or some type of health care, etc. But you want to put that information on a separate network that's only accessed by a VPN solution, concentrator, or something like that, to the outside world. So it requires, two-factor, multi-factor authentication, etc., to access it from the outside world. In the case of ransomware, Kirkton's, side of the fence saying, hey, I want to limit, ransomware or spillage of that data to the outside world. Was that beneficial, not beneficial, et cetera?
Yeah, so there's we have a number of mechanisms that can protect that in several different ways. For example, we have mechanisms built into the OpenShift cluster itself to say only and specifically these types of traffic can get in and on these particular ports and in these particular nodes. And that's just at the edge of the cluster, never mind the protections that we have in place within the cluster with network policies and the ability for any traffic to get in there further. For egress, we have several protections. There's something we've had for a long time called egress firewall policy, which is making egress rules that only the cluster administrator can define, and other people with network policy that, like project admins and developers, can't modify. That's being changed in the latest version of network policy that's upstream, with the advent of something called admin network policy, which will essentially grant this additional RBAC role for the cluster administrator to define exactly who's allowed to connect to the outside world and through to what IP addresses and ports. And so in this sense, the cluster itself has its protection mechanisms, but then our customers, in true sense of layering, they'll have additional devices at the just outside the edge of the cluster. Maybe it's a set of F5s, maybe it's something else that they have, where they do heavy filtering and VPNs and all the other things. So I think it's a rather complicated question to answer, in the sense that there's many different things in the cluster itself that can help mitigate those kinds of problems, as well as we have a lot of customers that have additional capabilities from, say, third-party vendors outside the cluster to assist with that effort as well.
And to add to that, so as Marc said, there's lots of ways to think about how to configure it. And some of what comes into play sometimes in a regulated environment especially is, what does your auditor recognize and comfortable with? Say you've got PCI DSS apps and those need to be segregated, or they need to be, within scope of, PCI DSS regulation. Do you want the whole cluster to be subject to PCI DSS, or do you want to separate that? And as Marc was talking, one of the things that occurred to me is that there's new functionality coming that will help also the hosted control planes. In addition to all the things Marc's already talked about, hosted control planes gives you a way to run the control planes as pods and have segregated, in effect, mini clusters that are just made up of worker nodes, still managed by the control plane, but that would allow you to have one set of worker nodes for those business critical apps in one environment, in one network environment, and a different set of worker nodes in a different environment. So that really does give you this additional separation. Now, for regulations, your control plane will still need to be part of that regulatory eval, but you can get this additional separation with hosted control planes. And we probably have links somewhere that talk about hosted control planes. I don't know if I can find one quickly, but I'm sure we can send something afterwards.
Right. The question I was thinking, and I'm not trying to steer it from a different thing here. And, I'm looking, from a zero privilege architecture, trying to understand both sides of the coin, if you will, that type of thing. That's what I was trying to understand. If you have something from a physical standpoint, is that better or worse than having a zero privilege architecture from that level? And like I said, I'm not trying to, hog the call from the time check standpoint.
Oh, and it's a defense in depth thing, right? So that if you can do it at a higher level, that's perfectly fine. But at the more levels you do it, the more secure it becomes. So this is specifically the way we do it for our container runtime environment. But we have additional layers below it. Indeed, we actually run on bare metal at the moment. We do have physical firewalls and stuff like that in place as well to cater for that type of security. And of course, to secure the out-of-band interfaces of the bare metals and stuff like that. So that's still in place there. So you do need that defense in depth still. But at least if you can do it on your own platform level, then you at least know at that level is secure, and the layers beneath it need to have their own layers of security as well.
Nice. All right, we are 1 minute over. David, is it quick? I love all the topics that you're bringing up. Thank you.
No, I clicked the wrong button. I'm sorry. I was trying to click the thumbs up thing versus the raise my hand type thing. My bad.
Oh, no worries. I like the little emojis that they have in here now. All right. Well, that was a great discussion. And thank you both Marcs for presenting and sharing both architectures with us. Well, zero trust networking and zero privilege architecture. I'll add those to the notes document and hopefully see you all in 2 weeks. And we'll post it to the regular channels. Thank you, everyone. All right.